Hello guys again. How are you? So far we have learned probabilities in chapter 1 and conditional probability in chapter 2. So from slide 3, we're gonna learn measurable locations. So when we have, so far we learned the frequencies. The frequencies were based on some data, we learned from first chapter. In the data set, the number of loads are the number of observation you're having, and each column represents the variable names. So those are quite important when you are doing the final project because you got to know, learn some programs based on some variables, how something affects something variable. So you got to understand the data structure very well. So if you are still confusing, please go back to the first chapter and look at the Excel file description I described. So the number of rows are each, represent the number of observations, and column is the variable again. So let's imagine we have some, list of data set. So now we want to know how that actually before I go further, let me show you some example of data set. Give me a second. This will be the data set actually I'm gonna share with you guys very shortly. It's in Excel file, it's college. You guys are gonna use this file for your final project. I will post this data very shortly. So there are, I'm excluding the first row because that is a variable name. We have a 777 number of observations. So again, each observation represents one sample. So for example, this universities. So each row represent with respected college names over here. And first column is what is a school name. Second one is whether they are private or not. And this is number of applicants. And this is number of accepted students given the number of applicants. And this is number of people who are enrolled. And this is top 10% of people who are graduating from high school. And then the next one is percentage of new students. Okay. Let me clarify this one more time. This is a percentage of new students from top 10% of high school class, and this is percentage of new students from top 25% of high school students. Class, and this is number of full-time undergraduate students. This is number of part-time undergraduate students. This is out of tuition, out of state tuition, and this is room and board cost. This is cost of a book, and this is a personal expenses. This is like a percentage of faculty with a PhD, and this is a percentage of faculty with a terminal degree, and this is students faculty ratio, and this is a percentage of alumni who donate. This is instructional expenditure per student, and this is graduation rate. So in the final project, I want you guys to choose some variables that affects the graduation rate. For example, I want to analyze, I want to improve the school because one of the important factor that affecting the ranking of school is graduation rate. So as the graduation rate is higher, then that means students are finishing their degree within certain year, like a 4 or 6 year, and they go and find a job. But if the lower graduation rate means that students cannot graduate, so they're not going to have any degree. So this is important factor. I want to you guys analyze. Okay, for example, how choose some variable like a 3 or 4 variable and analyze how those affects the graduation rate. So that we're gonna learn more deeply in the correlation and regression analysis, but this is something you guys should keep in mind. Take a look at this data set and what kinds of things are available, and just brainstorming, okay, what might be affecting graduation rate? For example, I mean, maybe, for example, student to faculty ratio. So that is just the ratio of the students to faculty. So higher ratio means there are, more number of students, or maybe, or number of faculty might be smaller than others. So lower number means good. So for each faculty member, there are 18.1 students available. For here, this college, they have 8.4. And you see some kinds of distributions over here. So, I mean, we're gonna learn some distributions really quick, but let me show you how to do some distributions over here. You just copy this one and go to, I think it was insert and recommended the chart, I guess. I think it was in histogram. Sorry, I usually do the R program, but I will show them maybe later. This is not okay. Okay, I will cover this later. I forgot how to create the histogram table over here. I think it should be somewhere over here. I forgot because I haven't used Excel for a while, but I'm gonna look up some information and send you. Probably this is Mac version, so it's not here. Usually under here said like some statistical analysis, and you should be able to see the histogram. But okay, I will show you in our program later. It's got to be something here, but it disappeared. Okay. But anyhow, these are some data structures we have. I want you guys to explore some of this, but we're gonna cover this more detail later part, but just, know some existence of the data sets. And now let's go back to the our lecture. Give me a second. So based on those data set, what we want to know is, okay, how do we capture those data sets? How do I describe those data sets? So one way of describing is, okay, what is the average of data set? For example, I know, we have about 40 students in our class. I want to know, what is the average SAT? I mean, what are the distributions of a SAT score when you came to the UAlbany? Or I mean, somebody might got 1500, or someone got maybe 1400, or etc. But the best way, the one of the useful way to describe is like showing what is the average SAT score those who are incoming to UAlbany, something like that. So in slide 3, we're gonna talk about those concepts like how the average can be used, and how to calculate those average. Sometimes we call average or mean. Those are exactly same word and same meaning. And next chapter, we're gonna learn about the standard deviations and variance, which describe how the data is distributed. For example, given same average, some data might be widely distributed. There are maybe more people who are bottom or more top than around the middle, which we will show you later, but this is just preview. Sometimes the data would look like this, but sometimes the data would look like this maybe. But they might have the same average, in both data set, but this one is more widely spreaded. So in the next chapter, we're gonna teach you how to calculate that and how to interpret those variances in detail. But for now, you don't have to worry about the shape. I will explain you very well, but just want to give you some motivations. Okay, the one way to describe those is a discrete statistic. This is something you guys need to show me later when you do the project. For example, I want to know the average of students to faculty ratio, or for example, if the average of students faculty ratio was like 12 in nationwide, again that was some number I just made up, but I want to describe it so that people who are looking at the data set or discrete statistic can get some sense of, okay, this is like a national average. And okay, you can compare this with some other data set you might be exploring, okay? So, one way of describing is the average, and others might be standard deviations that we're gonna cover in the next chapter. So this slide, we're gonna first define what is the random variables. And then part one, we're gonna learn mean. So mean is basically average, it's the same. And part two, we're gonna talk about median. So, and then, that is alternative to mean. So median has some advantage over mean. It is overcome some outliers that I'm gonna cover this later, and measurable relative standing. Okay, so the respective chapters, textbook chapters are 4.1 and 4.3. Yeah, this is our next slide. So based on this example, okay, what can you, you cannot calculate the average. Can you pause the video and try to answer this? So first thing is the price paid, make and model year, mileage, and number of major repairs. What is the answer? The answer is B, right? The make and model. So it's categorical variable. You cannot actually get some average of it. For example, some car might be Honda, some car might be, a Toyota, or maybe and Chevrolet or Ford, but those are some categorical variable we cannot quantify, right? But other things we can calculate the average and maximum and minimum. For example, we can get the average of price someone is paying, and average model years we can get it, average mileage or average number of major repairs. We can all calculate that. So because those are quantitative data set, so we can calculate the average, maximum, and minimum, variance, standard deviation, and medians. So random variable is numerical description of each outcome of an experiment. So for example, in previous cases, we flip a coin or we roll dice. So those are some random variable. That is actually from an experiment. So based on the experiment, we learned in first chapter what is an experiment, right? So like rolling a dice or flip a coin, those are some experiments. But based on the experiment, we're gonna have some outcomes, right? So those outcomes are actually, the random variable. So literally, it's random. We don't know what's gonna come up in the following number when you throw a dice. So let's say X be the outcome from rolling a dice. So X can take a value from here. It can be any number 1 through 6, right? Or Y is the stock market return. So we don't know whether stock will increase or decrease tomorrow, So those are something random variables. So in terms of notation, so the X denotes a random variable usually. So can take different value from different experiments. So like over here, it can be any number. So the capital X is a random variable, but the lowercase x is a specific outcome. It's not random. For example, I'm looking for the probability that X, which is outcome from the rolling of dice, equal 3. So I'm looking for probability that the outcome from the rolling of dice equal 3. So we know that is 1/6, right? or 13 point some percentage, right? So this one, little small one, is actually a specific outcome you are referring to, but this X, the capital X, is referring to the random variable, okay? So sometimes, I mean, we usually use that. This is fine, but sometimes you're gonna see some people are writing in this way. So this is X is this X. So because they know what they are talking about, so they just ignore this or only write down here, or they just put P sub X, the random variable of X, small x. So there are different notation, but in this class, we're gonna mostly use these notations. So again, this is random variable, and this is something outcome which is not random. Let's say we have n observations that might have some different outcomes. So this is a random variable x, and we have 1 over here and 2 and n. That indicates, okay, that is the first observation, this is the second observation, and nth observation. For example, if you are rolling a dice n times, then you just write down the outcome of that. For example, you are rolling 100 times. X1 might be 1, X2 might be 5, X3 might be 3, and etc. So those are something when you flip roll a dice, and these are the first outcome you are seeing, second outcome, etc. So those are types of variable. Let's say 2 students are nominated for Academic Excellence Award. These are some of the courses like microeconomics, macro, and econ statistics. And what else? The 420 is econometrics, I guess. Not sure. But the decision can be different depending on what you look at. I mean, which person do you think are doing better? They might have same average, but these people got more B plus, but these people got C. So one common way to compare is a GPA. So measurable location is a value that the data are centered or located around. So usually considered as a typical observation. So later you're gonna, based on some kinds of data set, you're gonna learn how to analyze some like a histogram tables or some distribution. So we are looking for some central tendency that is about here. That means it occurs most frequently, in the data sets. So it's a typical observation in the data set, or that means, most of the time you're gonna see most people will be around these values. So that we learn 2 measurable locations. So first thing is average, and the other is median. Those are quite a similar concept, but the outcome might be really different based on our data set. The average is also referred to as a mean, expectation, expected value, and this. This is like a notation for mean. So when I say, okay, what is the expected value of something? That is, I'm asking what is the average value of something, So mean, I told before that mean and average are the same. Again, we have another notation, expectation or expected value. Those who are taking some other mathematics courses or upper level economic course, you guys probably learned this. What is expected value of something, like that. So that is actually looking for mean. Mean and these are the same. So we have 2 different type of a mean. One is a sample mean, and the other is a population mean. So population mean is actually from the populations. We usually denote as here, this is a mu. This is like a mu. This is a mu. It's a Greek letter. So we use this to denote the population mean. When we have so many observations, for example, then we know this. For example, let's say everyone knows that the probability that number 1 show up when you roll a dice is actually 1/6. How do you know that? Because that is something we know. from the population. I mean, that is something, you know, when you roll a dice infinite number of times, that is something you're gonna see. Like 1/6 is actually the probability that some number comes up, you know, when you roll a dice. But sample mean is, I mean, given that you are doing some sampling, like let's say you roll a dice 50 times, and you are trying to identify what is the probability that certain number, like number 1 show up. And for example, you know, out of 50, you have like 5 out of, by chance it can be just 5/50 would be your probability that you're gonna have the probability that it's gonna be probability that the random variable x is capital X equal 1 is actually 5/50. So how do you do that? This is actually total number of observation, but this is total number of outcome IC number ones. So if you calculate it, it's 1/10, which is not equal 1/6. Well, that is actually one of the characteristics in sample mean, because we are doing some sampling. So it doesn't mean that the sample doesn't have to be equal population mean always, but when the sample size is small. But later, we're going to learn very important theorem, which is when you increase the sample size, this was only 50, and when your sample size increase close to the infinity, then the sample mean would equal population mean. So that is actually law of large number that you're going to learn later. Which means, you know, sometimes the sample mean and population mean might be different, but when you have enough sample size, it will be the same. So there is some probability that we're gonna learn later. So when you have a finite number of experiment, when you have a certain like a 50 number of experiment or something, and we're gonna observe something that is actually sample mean. So previous example I gave you also probability, but you can apply those concepts in the mean as well. So let me give you some example. This is a formula to calculate the mean. Let's say we have this number of observation, like n observation. These are different outcome. The mean is the weighted sum of data with each observation receiving an equal weight of this. So equal weight of this means, okay, everyone can calculate the average, right? Just adding all the numbers divided by number of sample, right? So this is how you guys calculate the average, right? For example, when you have this is number 1, 2, 3, 4, 5. Let's say you have a 5 observation. How did you calculate that? You just first add them up: 1 plus 2 plus 3 plus 4 plus 5 divided by 5. That is actually how you calculate the average. So you see a little bar over here that represents mean. So when you see some random variable and there is a bar on top of it, that means, oh, we are looking for mean or average of this value. So this value equal x1 plus x2 plus xn, but you can split this out by, actually this one is equal x1 over n plus x2 over n plus x3 over n plus etc. That means each observation you are multiplying 1 over n, right? So that is basically 1 over n times x1 plus 1 over x, 1 over n times x2, etc. So that is kind of like your weighting, you know, but this is exactly equivalent to just do this, but more advanced term, this is like an equal weighted of this. Why this is important? Because when we incorporate the probability, we might use some different weighting later. I will cover that. Let's say you have this observation, you have 10 observations, and these are some of the outcomes. So when you roll a dice 10 times, this might be the case. So for example, how many number 3 came up? It's like, okay, so there are 2. So probability that number 3 came up is like just 2 over 10 or 1 over 5, 20%, which is actually higher than population average, right? or population probability, but because that is again one of the I mean, because we have a small sample size, but later we're gonna learn some more property. But anyhow, to calculate the sample mean, you just add all the number. So when you add this number, it will be 34, and you divide by sample size. So that is a 3.4. So on micro Excel function, you use average to calculate that. Okay, so it's quite easy, right? Okay, and when the probability is given, the mean is a weighted sum of a possible outcome weighted by the probability. For example, let's say you have this value. You have a 99% of probability that you're gonna win $0 or nothing, or you have a probability of 1% probability that you're gonna win $100. What is your expected value, or what is the average, or what is the mean of this value? You know, the wrong calculation would be, okay, I know this. We have a two sample. We have two samples, so we divide 2, first add 0 plus 100 and divide by 2, so $50. No, that is not true, because we need to take into account this probability. Do you guys remember, or have you guys learned how to calculate the average when you have a probabilities? Okay, I'm gonna show you. First thing, you need to find the weighted outcome. So previously, the weighted outcome over here is you divide everything by 1/10, or here it was weighted over 1/n, you know. That means each of them will have equal weights. In other words, in the previous cases, when you had certain numbers like that, you just add them up, divide by 10 or equal weights. Each of them will account for 10% of each weight. But now this one is 99%, this is 1%. So you need to multiply the price times the probability and find the weighted outcome. So 0 times 0.99 is 0, 100 times 0.01 is 1. So sum of the weighted outcome is your average. That is very easy in probability. First, when you have these two, find the weighted outcome just by multiplying these two and just add them up. That's it. Yeah. So you don't have to divide by number of a sample, because in probability, it's already taken into account those sample sizes. You know, so you don't have to worry about this one that much. Okay, the idea actually for here is as follows. Let me show you another way of looking these data sets. Okay, let me say there are number 1 and number 2 and number 3 and number 4 and number 5 and number 6. So these are some of the outcomes, and we can get the frequencies of this in this table. So let's say how many of number 1 came up out of here. So this is again frequency. I will not write over here, but this the number I'm gonna write is a frequency, and this is actually value of axis, because we have a 1 through 6. So I just wrote here. I'm counting how many number came up here. So number 1 came up how many times? 1 and 2, so 2 times. And number 2 came up how many times? 1. Is it only 1? Okay. And number 3, how many times? It's 2 times. So this is a frequency. And number 4 came up 1 and 2, 2 times. And number 5 came up 1, 2, 2 times. And number 6, 1 times. So is it 10? Summation of this is 10. Yeah, 2, 2, 2, 2, 1, 1. Yeah, 10. So we have a frequency of this. So I'm gonna write now. So frequency is like that. So this is a random variable x, and based on that, you can write down the frequencies. Okay, how many number 1 random variable number 1 came up? 2. and how many number 2 came up 1, etc. So how many observation did we have? It's number 10, right? So we had a 10 observation. And you remember in previous slide, how did you get the calculate the probabilities out of this, like a frequency table? This is from actually first chapter. We were able to find the probability based on the frequency table. Do you guys remember? The idea is, okay, just 2, we have a 2, but how many samples do we have? It's 10. So 2 divided by 10 is what? 2 over 10 is what? 20%, right? So this is a 20%. So 2 over 10 again. So number of frequencies over here. So 2 over total number of observation 10. Similarly, this would be what? 10%. I will just ignore percentage. But this is how you do the 20% and 20%. 20%, and this is also 20. Sorry, it's trying to correct itself. Okay, and 10%. So, oops. Okay, so the next thing you guys need to do is, so one way you can get is like that, but I'm showing you that basically the probability and this one both are exactly same method. It doesn't matter which method you are using. So one way you can do is just add them up, 34 divided by total sample. That is based on assumption that each of them are having same weights, but when you convert this to probability table, and you can follow this method. So previously, how did you do that? Over here, sorry. Now you are having probability from frequency table. So you have this random variable x, you multiply and get the weighted outcome, right? So let's try to do that. So now this is a random variable and this is probability. How did you get the weighted outcome? Just 1 times 0.2, which is 0.2, right? So let me just write down over here. So that is 0.2. So that is from x equal 1. So 1 times 0.2 equal 0.2, and 2 times 0.1. This is a 10%. That's why 0.1. I multiply x times the probability, like we did over here, like a price times probability, to get the weighted outcome. So 2 times 0.1 equal also 0.2. And 3 times 0.2 equal 0.6. So these are weighted outcome, and 4 times 0.2 equal 0.8. And 5 times 0.2 equal 1, and 6 times 0.1 is 0.6. So it's 1 and 0.6. So we got weighted outcome from x equal 1, x equal 2, x equal 3, x equal 4, x equal 5, and x equal 6. Now what did we do to get the weighted outcome or average, population average? You just add all the weighted outcome, right? So that will be just add all this number. That is, 0.2 plus 0.2 is 0.4 plus 0.6 is 1 plus 0.8 is 1.8 plus 1 is 2.8 plus 0.6 is 3.4. Let's figure out whether we get the same result. So summating this is equal to 3.4, right? So let me get rid of this. And we got same 3.4. So it doesn't matter which one you're using, but you got to understand the concept of weighted and then just sample mean. I know basically everyone can use this method to find the mean, but I think what we are adding, comparing to the previous things you have learned, is a probability. So now you got to take into account the weighting. So why weight matter? For example, this one, each sample represents just one observation. But for example, this kinds of probability, maybe there might be, if there were 100 samples, that means 99 out of 100 samples might get price equal 0, but only 1 out of 100 would get $100. So when you calculate the average, so using this method, you do like a 0 plus 0 plus 0 plus 99 times plus 100 and divide by 100, which will give you exactly 1. So, I mean, try to spend some time on this. It might not be really obvious initially, but when you guys are trying to go over this material again and again, in the end, you're gonna realize, just try to look at this. Okay, we are having equal weights, and think about what is the meaning, and why they have different weights, and why do we even calculate weighted outcome? Because those are basically same concept. I just prove you guys. You guys can calculate this using just add them number, divide by this, or another way of doing it is using probability to get that. Sometimes this might be really easier because when you have a couple million of observations, having probability is much easier way to calculate the mean, So please spend some time on this, okay? So these are some examples. So number of cars sold per day are 50 days. So these are some frequency table. There are 25, days that out of 50 days, 25 days, you sold 0 car, and 20 days you sold 1 car, and 4 days you sold 2 car. 1 day you sold 5 car. And let's find the sample average. So imagine you actually have a 50 sample, so it might be 25 of this means actually you might have 0 this, 0, 0, 0, 25 times, 25 times plus you have a 1, 1, 1, 1, 1, 1, this 20 times, and you might have a 4 of 2, so 2, 2, 2, 2, and you have a 1, 5, that is over here. So when someone asks you, or if I ask you to find sample mean, you just add this number, everything divide by 50, right? So that is how you calculate, right? How many of, so if you add in this number, that is 0, 25, so it doesn't matter. So it's gonna be 0, and plus 20 of this is 20, plus 4 over 2, so it's 8. So it's 28 plus 5, it's 33. So 33 divided by 50 is what? It's a 0.66, right? So that is actually your average car sold per day. But this is one way everyone would know this method. But I want you guys to understand this is basically what you have learned so far in high school. But though you can convert this to frequency, and you can convert this to probability, and you can get the average out of probability. That is something I want you to take out of this section. So you first convert this to probability. So from first chapter, 25 over 50 is how you get the probability. It's 0.5. 20 out of over 50 is 0.4 or 40%. This is how you do that. And how did you do the next step? Is you find a weighted outcome. Let's say WO, weighted outcome. How do you do that? It's 0 times 0.5, which is 0. So 1 times 0.4 is again 0.4. Yeah, you might want to pause this video and try to answer this one first, but I'm just giving you the answer. And 2 times 0.08 is what? 0.16. And lastly, 5 times 0.2 is actually 5 times 0.2 is 0.1. So it's gonna be 0.4 plus 0.16 plus this is 0.66 or 66%, which is exactly same as what we get. So that was actually 0.1. So 0.1 plus 0.16. Sorry, this should be 6. And it's a 0.4. Okay, so this is a weighted outcome. And the first one is actually 0. So 0 plus 0.4 plus 0.16 plus 0.1. Again, those numbers are coming from weighted outcome. So outcome times probability. So 5 times 0.02 plus 2 times 0.08 plus 1 times 0.4 plus 0 times 0.5 is 0.66. That is exactly same as your mean. So one way of doing this is you understand frequency. Oh, I know this distribution. So you find add everything and divide by 50. That is one way. The other way is using probability. But this is something I would emphasize. Basically, both are equivalent. It doesn't matter which method you're using as long as you understand. Okay, so you just find the weighted outcome, just add them up. Boom. Okay, next thing is, okay, we want to use some average to make some decisions. When the, from economic courses, when the benefit is higher than cost, we want to keep the job, right? I mean, we want to just doing what we are doing, but if cost is higher than the benefit, we don't want to do that, right? So suppose that from profit from selling a car is 3,000. The wage for the salesperson is 2,000 bucks per day. Oh, it's very expensive. Yeah, but let's think about whether he deserved the salary. So, I mean, based on this, what would you guess? How do we know whether he deserved the salary? So, you know, the cost information, this is a cost and this is a benefit, right? So we want to find, this is cost per day. This is, the profit from selling a car. And, we want to calculate the net benefit or net profit, right? That is revenue minus cost. This would be revenue minus cost, but you don't use this directly. This is a profit from selling a car, right? But how many do we sell on average? Is 0.66, right? So what you need to do is, first find this, there are a couple of ways. So let me, let me go over with this view a little first, and then I will cover the thing I was just about to tell you. Either way would be fine, but let me go with this one first. What you want to do is, we know these were the distributions from this table, right? So number of cars, 0, 1, 2, 5, and these are the frequency. And based on the frequency, we got the probabilities. And so the next thing you want to do is, okay, put some profits over here. So for example, if we are selling 0 car, what is your profit? Is negative 2,000. Why negative 2,000? Because you are selling 0 car, but you still need to pay 2,000 bucks. How about when you are selling 1 car, what is your profit? It's 1,000. Why? Because when you are selling 1 car, you earn 3,000, but you are paying 2,000. So 3,000 minus 1,000, 2,000 is 1,000. Similarly, this is, you can fill out this number, and these are the probability. So the next step you want to do is a weighted outcome. So weighted profit, which is negative 2,000 times 0.5 is negative 1,000. 1,000 times 0.4 is 400. Do the thing, just add them up. So negative 200 bucks is the expected profit or average profit you would expect, So, so that means what? So on average, you're making 20 bucks loss. Then you don't want to, keep hiring, right? So the easier way of doing is, like that. So but the thing I was gonna talk to you initially was, previously we found that the average or mean number of car sale was what, 0.66, right? Then we are making 3,000 if we are selling a car like that. So how you can do is, okay, so profit or expected profit is like, let's say just profit. Actually net profit, I would say NP equal what? The whatever profit you're having, 3,000, 3,000. Yeah, these are all zeros, by the way. And 3,000 times expected number of car sale, that is what, 0.66. and minus what, 2,000, right? This is per day. So this is net profit, expected net profit per day. So 3,000, which is the profit from selling a car, times your expected number of car sales, which is average. Expected is again average again, is 0.66 minus 2,000. If you do the math, this would be 1980, right? 1980 minus 2,000 is what? Negative 2. This would be basically equal negative 20. So those are exactly same as using this method, finding this, and we use weighted outcome, etc. This is exactly the same. So profit times expected car sales. So 0.66 is coming from here. Just go back to this slide and come back. And minus this is negative 20. So it doesn't matter which method you are using, but this is how you do that. So negative 20, we got the same outcome. You can find the expected profit and just add them up, and you can make the average, or you can use that. Okay, since we know the expected number of cars sold is 0.66, so this, someone can make this much on average, and expected profit is just multiply this minus 2,000, which is here. So same, exactly same method. Yeah. Okay. So more formally, expected value of y, so which was expected profit I had, is equal 3,000 times expected value of x minus 2,000. So we know the profit equal net profit equal 3,000 is a profit for each car times number of cars sold minus 2,000. We take the average of this. So expected value of y equals 3,000 times the expected value of x minus 2,000. So our average or expected value of y was 3,000 times 0.66 minus 2,000. This is something I just covered. So okay, so this is another example I want you to take a look at. Please pause this video and try to answer this one, okay? So we are looking for a number of movies we are going to watch in the theater next month. These are some distributions like probabilities. Suppose a ticket is 15 bucks. What is the expected spending on a movie ticket next month? So you might want to pause this video and try to get the expected spending over here. So I will leave you the answer. The first thing you want to do is like you did over in previous question, we found the expected profits. So with respect to the each car sales, so like a profit is negative 2,000 if we are selling 0 car, and profit is 1,000 if we are selling 1 car, like that. You just do the same thing. So if we are having 1 movie, what is the expected ticket cost? It's 15 bucks. So if you are watching 2 movies, it's 30 bucks and 45 bucks. So these are some expenses, and you know these probabilities, right? It's from here. And you get the weighted outcome by multiplying these two, which is 6 bucks by multiplying 15 times 0.4 and do the etc. And the next thing is just add them up. This is your expected spending. So answer is D. Yep. Or the other way of doing it is, okay, so what is the expected number of a movie you are singing is 1 times 0.4 is 0.4, 2 times 0.4 is 0.8, multiply. So you, on average, you are expect to see the movie 1.8 times. So multiply 1.8 times 15, 27. Exactly the same answer. Either way would be fine, but it's not always equal depending on the question. So I'm gonna show you what that means. Let's say there is a deal offering 2 movies for 25. What is the expected spending on movie? Now you can do the same thing. So try to do this yourself, and then we can reveal the answer, which is, so if you are watching one movie, you're still paying 25 because you already bought for ticket for two, but you are watching only one time because uh, um, even if you watch only one movie, you need to still pay 25. So expected cost is 25 and 25. And if you're watching one more, 25 plus 15 is 40 bucks. And multiply them, it would be 28 bucks. So it was 27 without the deal. So you don't want to take the deal based on some probabilities, right? So let's say a gold membership to a theater, like a $5 monthly fee, but 12 bucks for ticket. It used to be 15 bucks. So what is the expected spending? So if we do the same thing, if we are watching one movie, how much money you're saying? So 5 bucks plus 12 is 17. How about if you are watching two? So 2 times 12 plus 5 is what? 24 plus 5 is 30. If we are watching 3 times 12 is 36 plus 5 is 41. So these are expected your cost and times the probability. You multiply that and add them up is 26.6. It's lower than 27, so it might be more deal for you. So you can calculate using changeable unit rule by getting, on average, you are expected to see the movie 1.8 times. 1.8 is coming from here again. Over here, this is using changeable unit rule. This is how you get the 1.5 or average number of movie times this. So 1.8 times 12 bucks, which is a movie cost, and plus 5, 26.6. The one thing you might want to notice is, here, the change of unit rule might not be appropriate because the cost is not a function of the number of movie because you got to pay 25 no matter what. So except the second question, you can use the change of unit rule like you did here. So each of method would be fine. So choose something you're convenient, okay? So the second question was not linear. So as I told you, as the number of movie increase, the cost is increased linearly, like increased 15 and 15 and increased 12 and 12, but it didn't increase. It was 0 and 15. So it's not linear. So change in unit rule or multiplying 1.8 or average number of movies you are singing, you cannot multiply that. So this is another example, like a probability distribution of your wireless data set. So usage is this and probability is this. So which one would you choose? Like unlimited wireless data plan for 40 bucks or 2 gigabyte data plan for 35, but you pay 20 bucks if you exceeding 2 gigabytes. So you can make the optimal decision based on these distributions probabilities, right? So let's look at that. So before I do that, can you guys decide which one is more economical for you? So you might want to pause this and do some calculation, okay? So let's say expected cost for unlimited data is 40 bucks because you're paying no matter what 40 bucks, so you don't have to think about others. But the cost for plan, for the second question, you need to think about that. So let's say if we are using less than 1 gigabyte, how much you are paying? 35. How about if we are using 1 to 2 gigabytes, you're still paying 35. But if we are using more than 2 gigabytes, you're paying 35 plus 20, which is 55. So you get the cost and multiply the probability and get the weighted outcome. Add them up, you get 39. Your expected outcome cost is actually lower than 40 bucks. So actually 2 gigabyte plan is better for you, even if there is a chance that you need to pay 20 bucks. So that is how you make the decision based on some probability or expected value or based on averages. Okay. Okay, I'm gonna cover this more detail when I cover some data sections. So the thing I want to cover is a median. So let's say let's come back to the previous data sets over here. something we covered earlier of this course was here. Let's say we have this data set. If you write in the ascending order is 1, 1, 2, 3, 3, and 4, 5, 5, 5, 5, oops, 5, 6. So is it right? So how many? 2, 4, 6, 8, 9. Did I miss something? 1, 1, 2, 3, 3, 4. Oh, 4. Okay, another 4 over here. Okay. So we have a total of them. So how did you find the median? I mean, I know you guys can get the median. Everyone can do that, right? So just eliminate this one, 1 and 1. So first you do this in ascending order and just delete 1, 1, and okay, and just eliminate. Oh, okay. So lastly, you have a 3 and 4 because you have a 2 left. Let's imagine you have only 1 left, then that is your median. But if you have 2 number, you just add this number and divide by 2. So 3 plus 4 divided by 2 equal what? 3.5. So that is your median. This is how you calculate the median. That is something you probably know in previous, I mean, in high school, you know. So this is a method you have learned so far, but something I'm gonna teach right now is based on some rule using probability. So the rule for the getting median is this. So as long as you satisfy this equations, then I mean this formula, then that is median. So what is this meaning is the x was a random variable, right? So probability that any random variable is less than or equals certain value. So this is some specific value. Previously it was a small lowercase x, but now we just replace this to m. So m is the median. So probability that x is less than or equal m should be greater than 50%, but also at the same time, probability of x, random variable x greater than equal m is also should be higher than 50%. As long as you satisfy this, then that is a median. So this is how you do the formula. Okay, let's now look at, okay, how do they know the percentage, etc. So I will explain you over here. For example, okay. So each of, in this example, each of them have only one frequency. So they have basically 20% of probability each, because the reason why it's 20% is each of them are appearing only one time. So only one frequency. So everyone has the same weighting. So 20% each. But okay, so rearranging this in ascending order. So something in the middle is median. So this is how you calculate that. So we first need to find the probability, cumulative probability. For example, probability that x is less than or equal 1.3. So less than or equal 1.3 includes what? 0.6, 1, and 1.3, right? These three. So what is the probability that x, any random variable less than this one, is included 3. So add the 20% plus 20% plus 20%, that is 60%. So adding this probability is cumulative probability, something I'm going to cover in detail later, is 60%. Also, probability that x is greater than or equal 1.3, that is 1.3, 3.6, 6.5, so 20, 20, 20 is also 60%. So that means, okay, they are satisfying median, so that's why median. You can try 1. For example, probability that x is less than or equal 1 is what? 20% plus 20%, oh, it's 40%. So which is less than, 50%, so it doesn't satisfy the first equation, so it's not working. You can try with the other thing, but only 1.3 will satisfy this equation. So this is very important. It's gonna be in your homework, and potentially I'm gonna ask in the exam. So, but how do we know this is 20%? Because this is only single observation. So if you are still confused with this probability or equal weighting or weighting, go back to our previous lecture. I mean, so early of this chapter and take a look at in detail and look at your textbook as well, okay? Or by all means, just let me know if you guys have any question. Let's say we have some more observations and this is ascending order. What is a meter? You eliminate this. Okay, there are only 2 left. So you just add them up, divide by 2 is 2.35. So, okay, so you can similarly do the median of this. You can pause and get the, so first do the ascending order and find it. So you might want to answer independently. Just pause this video, answer it. So now things are getting harder when you have more than one. So far, we have only 1 observations, but now we have a frequencies, right? So things will be much harder. I mean, it's not hard, it's easy. So you first find the probability, right? And then next thing you want to do is find the cumulative probability. I would say CP. So CP represents a cumulative probability. So it's a cumulative, literally, it's like you are actually accumulating as you go. So initially it was 28%. And when you add these 2 numbers, it's what? It's 49.5, right? 49.5. This 49.5 represents what? That is actually probability that any random variable of x, so that cumulative probability is probability that any random variable x is less than or equal number 2, right? So basically probability that x is less than or equal to equal 1. So basically this probability equal probability of x equal 1 plus probability that x equal 2, right? This is equal to probability that x equal 1 and plus probability that x equal 2, right? Probability that x equal 2, right? X equal 2. So basically probability that x equal 1 is 28%, probability that x equal 2 is 21.5, so add them up, it's 49.5. So that is how you get this cumulative probabilities out of this single probability. Okay, so similarly, you can find the probability that the x equal less than or equal 3. So that is actually here, that is cumulative probability of this, which is a probability that x is less than or equal 3, equal what? So that is a probability of x equal 1 plus probability x equal 2 plus probability x equal 3. So add these 3 numbers. So that is the concept of cumulative probability. So using cumulative probability, these are how you get the number. For example, probability x equal less than or 2 equal 49, etc., etc. So so we want to find the median. So that should satisfy the 2 conditions, right? So again, these are the 2 important conditions. Here is very, very important, okay? So we want to find, okay, some try and error thing. Like, okay, let's imagine number 2 is our probability. Then, probability x is less than or equal is, 49.5. I was told that it should be greater than equal 50%, but this is actually lower, so definitely 2 is not the option. Similarly, 1 is not the option. How about number 3? So a probability that x is less than or equal 3 is 68%. How about probability that, so the other condition is the probability that x is greater than equal 3 was what? It should be higher than 50%. How do you get this? This is basically you added this number. That includes probability that x equal 3 plus probability that x equal 4, probability that x equal 5, and probability x equal 6. This is actually using complementary rule. This is equal 1 minus, because summation of probability is always 100, 1 minus probability that x is less than or equal 2, right? So this is how you get that. So what is the probability that x is less than or equal to? It's 49.5. So 1 minus of this is what, 50.5%, which is greater than 50%. So it satisfy first condition and satisfy the second condition, boom. So these are the median. Number 3 is the median. You never do this like that. Okay, for example, you are sending 1, 2, 3, 4, 5, 6, and okay, so 3 and 4 are median, so you just add them up, divide by 2. That never happened. So because you are having frequencies, so you never use that method anymore. Because you need to take into account weight and number, because some numbers are more than others. For example, number 1 appears 28% out of 100 times, but number 6 appear only 7%. So you need to take into account that when you calculate average and median, etc., etc. Okay, even standard deviation in the next chapter. So next thing you want to do, so this is equivalent to just add this number, 18.5 plus 14.5 plus 10.5 plus 7 is equivalent to this. Either way is fine. So let's try with the number 4. So probability that x equal less than or equal 4 is 82.5. So it satisfies the first condition, but probability that x is greater than equal number 4 equal what? Number 4 equal basically 1 minus probability that x is less than or equal number 3, right? So that is a 1 minus 68%. That is a 32%, which is lower than 50%. So 4 doesn't work. Or you can add this one like so x is greater than or equal 4 is a 14.5 plus 10.5 plus 7. Either way it would be fine, but it doesn't satisfy the median. As a result, number 3 is your median. This is how you get the solution, okay? Okay, this one, what would be the median? You can actually find the cumulative probability. Please pause this video and practice on your benefit. This kind of types of question might be on the exam and also your homework as well. So make sure you guys practice enough. Pause this video, okay? Don't look at the answer yet because I'm not gonna grade this, but for your own benefit, okay? So what would be the median? And I will reveal the answer right now. So first find out the cumulative probability and do the same thing as we did. So this would be answer. Check whether that is your answer. For example, probability that the interval is less than or equal 4 to 6 is 64%. So it satisfies the first condition. And what is the probability that the x, some random variable interval x is greater than equal 4 to 6. So that is what? That is basically 1 minus probability that x is actually less than or equal 2 to 4, right? So 2 to 4. So 2 to 4. So what is the probability that x is less than or equal 2 to 4 is 46%. So this should be 54%, right? So 54%. So in other words, this satisfies the second condition as well as the first condition. So that's why this is median. So please take a look at this. Okay, so okay, percentile. Okay, this one I will cover this more later when I do some data work. But this will be enough topic for you to do the homework. So just try to look it up to this point. Okay. If you guys have any question, by all means reach out to me. Okay. Okay.